embracing. So it's a very important data is a very important asset to any company you could possibly think of. Now, why is data analytics important? So basically, why do you need to know about data in the first place? Why do you need to know about this information in the first place? Well, as I said, businesses have within the recent years, numerous companies have been embracing big data as a method to gain an advantage over their competitors. So many companies have realized, hey, I have all of this information, and maybe I can actually use it for more than just, taxes, for more than just administrative things. Like, maybe I can actually use it for something maybe I can actually use it to accomplish my goals rather than just, rather than using it in the traditional ways that I'm expected to use it. And as a result, a lot of entities within really any space have been utilizing data in order to gain an advantage over the other entities within their particular space. And one of my, if anybody is from the United States here, or has lived in the United States in 2008, Barack Obama was known as one of the first major candidates to really take advantage of utilizing big data for their campaigns. So you can see this image was taken from the Washington Post, where Barack Obama is called the big data president. And you can see that data is literally used at the highest level, is literally used in the highest echelons of American politics and American business and stock trading. Every single facet of not only like the corporate world, but also in Americans or in society, like utilizes big data in some way to gain an advantage over their contemporaries. So I thought this was a very powerful image to illustrate, to essentially illustrate how data is used within, with how ingrained data is and how important it is to any industry or profession within the or within any nation, really. And as written here, like, data also is known to be a multi-billion-dollar industry due to these utilities. Now, so I'm not going to read this point by point, but essentially this slide breaks down the different types of data that you'll encounter when you're looking inside, when you're working in the field, or you have an Excel sheet full of records that you're trying to dissect. Essentially, a big split or schism of data that you can kind of sort a lot of information into is, you can ask yourself if it's categorical or numerical. In the science world, a lot of people say quantitative or qualitative. Basically, this is just saying, is this information actually measurable, or is this information just a descriptor, like a non-related descriptor? So there are lots of ways you can split these categorizations when you're working with different data sets. And the reason why this is important is that it kind of changes what kind of analytical tools are available to you when you're approaching this data set. Like, for example, if you find numerical data can be plotted in far different ways compared to categorical data, and it's effective to understand those differences. And I will get into some of the techniques you can use to plot numerical data versus categorical data a little bit later in this presentation. But some of these other things are also, or these other things are also really important. So just breaking down categorical data, you can kind of consider the two differences to be categories that can be ordered and categories that can't. Like a good example is like pant size is a good example of category that can be ordered, or shirt size. You have small, medium, large. Starbucks, they're, what is it? It's tall, grande, and venti. So that's a good example of ordinal data where you know that you don't really, at a glance, you don't really know what that entails, those categories, but you do understand the general size, or you do understand what, that there's some order there. And then discrete versus continuous, you essentially you can just think of it as discrete are numbers that can only take on certain, or discrete is a scale that can only take on certain values, and then continuous is a scale that can take on an unlimited number of values. So discrete is where something will just be whole numbers. Usually it's to define like only whole numbers, like you only count one, two, three. For example, like if you're taking a test and most of the time, a lot of points on a test are very solid whole numbers because you either get the answer or you don't. So that would be an example of discrete. And then interval and ratio. This is where things kind of get a little bit complicated because essentially you can consider ratio having a defined 0 point and then interval where the 0 point is kind of arbitrary. So like a good example of again, these are very debate, like there are a lot of scales that are pretty debatable. Like height is one of those that's debatable since it can be found that technically no one can be 0 inches tall, so therefore it has an irrelevant 0 point, so therefore it's interval. But then some people will say no, like height you can't have a 0 because 0 exists on the height scale, therefore it could be ratio. So there are debates around these numbers. And then of course you want to consider if a variable like acts throughout time or is a snapshot of a singular point. So yeah, just kind of something to think about when you're approaching data of all different types. And if this is a little bit overwhelming to you, you can look at this variable type relation diagram that I put right here. If you see your variables, you can split it into categorical, which is nominal and ordinal, and then for numerical, discrete and continuous, and then on the continuous scale, you can see it split it further into interval and ratio scales. Yeah, so some important concepts that kind of attribute very well to data analysis, and some important concepts that really help when you're looking at data is you can kind of consider data to be a variable within that has a distribution. So essentially you can consider variables the values that your data can take, and the distribution as all of those values that are possibly available for your variable. Now, essentially these are just fancy words for saying these are the numbers within your data as a whole, or within one particular attribute as a whole. Now, within those numbers, there are numerous ways to look at them. One thing that I always like to default to is mean and standard deviation. So, of course, like there are other ways to define what these are looking for, but essentially this can boil down to what is the center of your distribution and what is the spread around that center. So, a good example is if you have a lot of students and you're measuring their heights, and the average height is like 5'5", that how strong it, like how many students are actually centered around 5'5"? Like, are people usually in the 5 foot range, in your distribution, or are people spread out? Like, are some people in the 4 foot range, or some people in the 6 foot range, or some people in the 7 foot range? That's what causes the spread. So typically, when you have a spread in a distribution, that means that your variable can take on more values compared to one that's like very close together and having a low spread. So it's always important when you do a lot of like center analysis, like mean, you also consider the spread too. Then some examples that we might get into a little later is a percentile and then median. Uh, so you can kind of consider a percentile is like if you pick a number within your distribution, how many values within that distribution fall underneath it. So like say you're like 8 feet tall or some ridiculous height, you you can say that, oh, like 99% of all people fall underneath me, so therefore I am the 99th percentile. And then median, you can kind of consider that the 50th percentile. And then minimum and maximum, these are speak for themselves, just the highest and lowest values in your distribution. And then you have outliers. So going back, most of most heights for men, for example, might be around like the 5 foot range. Might be around the 5 foot range. If somebody is like 8 to 10 feet tall, that would be considered an outlier. And outliers can have very interesting effects on your distribution. They can mess up your analysis. They can mess up your statistical testing. So it's always important to watch out for them whenever you encounter those values. So many times, a lot of outliers are due to poor data entry or some kind of bug in the recording software. So if you're like recording temperature and you get a temperature of, and you're in like a very temperate zone and you start getting temperatures of like 300 degrees Fahrenheit outside, yeah, that might be a problem with your that would be considered an outlier, and that might be a problem with your equipment because of course having a temperature of 300 degrees Fahrenheit outside is going to be, pretty much impossible. Unless the sun crashes into Earth or something like that, right before the sun crashes into Earth or something like that. Yep, and you can see these concepts visualized from the previous. You can see the outliers visualized on this distribution. You can see how the median is visualized. You can get an idea of how percentiles are visualized as well. And you can get an idea of the mean and standard deviation within a distribution. So just some visuals some aids to assist in those concepts, because again, a lot's coming at you at the same time. Now once we get onto that, we want to start telling a story with our data, and a very effective means of telling that story is through visualization. So this is what I was hinting at before when I was saying it's always important to consider what type of data you're working with, because it could because certain visualizations help tell the story of data better than depending on what type it is. Some of these might sound very familiar to you, like bar charts and multi-bar charts and scatter plots. So bar charts and multi-bar charts can be very good for displaying categorical data, typically displaying categories with respect to a certain value. So many people like to use quantity when using bar charts, like how many times does this category appear in your data versus this other category. Scatter plots, multi-bar charts can be good for determining relationships between categorical variables, and then scatter plots are very good for determining the relationships between numerical variables. Again, it's very important to consider what kind of data you have, because it might be the difference between, is a scatter plot more effective for telling the story or a bar chart? Histograms too. Histogram, you can kind of consider that, as I said before, what are histograms and box plots? What are the best ways to look at your distribution? Well, if you look at histograms, they'll give you this collection of bars that are next to each other that'll give you a good idea of how numbers are distributed throughout your distribution. So you can see, oh, hey, there's some spread over here. This one is probably an outlier over here. So very effective for getting an idea of your relationship at a very high level. And it's very similar for a box plot too. It can give you a lot of interesting statistics. Now, one important chart that I haven't gone into is the line chart. And that's because line charts are very, very useful for analyzing the behavior of a numerical variable with respect to time. So I will get into some examples over here, but line charts, very, very useful, particularly in Wall Street and in the stock market. Whenever you look up a certain stock, like if you want to look up the S&P 500, typically it's plotted, that value is plotted over time using a line chart. So you can kind of see a histogram here. You can see that all the values within the distribution are binned within, are put into certain buckets, and then the frequency is added to those buckets when a value falls within them. You can see the difference between single and multi bar charts. You can see that different categories are being compared, and you can see how those categories can be related. You can see the difference between the names of those people on the x-axis, and you can see how bar charts are different colors. So you can see how different names differ within the subcategories. Scatter plot, you can see how wind speed and temperature seem to have an inverse relationship. As wind speed tends to increase, so does the temperature. As temperature increases, you can see the wind speed start to go down a little bit. I'm so sorry. And you can see that downward facing line with it. It's a lot of trends. It's very useful for detecting a lot of trends, and it does make sense in this context because as wind speed tends to increase, it tends to get much colder. So wind chill. And then you can see the outliers. Again, like I'm bringing this plot up again. This is what's known as a box plot. Very useful for plotting your distribution. You can see your skews, you can see your outliers, you can see how they compare to what's determined as what's supposedly the minimum and what's supposedly the maximum within your distribution. A lot of good information about your distribution can be gleaned from a box plot similar to a histogram. And then this is a good example of a line chart. You can see how sales are mapped out throughout the years. So kind of an overview. Data is a multi-billion-dollar industry. There are numerous domains and across numerous different companies, and you can use data really well to tell a story. As for next steps, Python and SQL are very useful for pre-processing data, and Tableau and Microsoft and Power BI are very useful for dashboarding. And you can go into data science, which is essentially using predictive analytics to extract the actionable insights, and that's based on the foundation of these analytical concepts. So yeah, that's pretty much everything. Thank you for attending, and I really appreciate your time.